Okay, so yeah, I thought of making this video so that we could go over these homework questions because we don't have enough time in the lesson. Yeah, and then some of these questions are really difficult ones as well. So we're gonna try to go over all these questions, and hopefully we might take away something new that we haven't discussed in the lesson as well. First one's really easy. We've got to basically complete the square. So we have x squared minus 8x plus 5. Now remember the technique. You're going to halve that number. So that's going to be minus 4. So this is going to be x minus 4 squared. Pick this number, square it. So negative 4 squared, that becomes 16. And you're going to subtract that number outside of the bracket. So this is x minus 4 squared minus 16. Then you have a plus 5, which means my answer now becomes x minus 4 squared minus 11. That means your A would be 4 and your B would be 11. Now, it is a very common mistake to take A and write it as minus 4, but remember they've already given us the negative sign there, which means A is not negative 4, your A would be just a 4. Same goes for B as well, the negative sign is already there, so B should be just 11. So that was the first question from the Mathswatch homework. Second one also looks pretty straightforward. So where's the second one? Yep. Second one is again same style, nothing much difficult there. We just have to complete the square. So that's x squared plus 4x minus a 7. Half that, so that should be x plus 2 squared, then take that number, square it, and then subtract it outside of the bracket. So that would be minus 4 minus 7, which means we're talking about x plus 2 squared, and then minus 11. So your A would be 2, and then B would be 11, not minus 11, because the negative is already there in the question. Number 3, again, this is also too easy, nothing much difficult in there, but we'll still do it nevertheless. Again, completing a square, this time because it is a 3, things might be a bit more difficult. So what we're going to do with the 3 is, that's going to be x plus 3 over 2 squared. Take that number, square it, so that's 9 over 4. Subtract it on the outside, and now I've got a plus 4. The idea is the same, it's just that because we've got fractions, things are slightly difficult. So if we remember our lesson on fractions, I need a common denominator. This is 4 over 1, so times by 4 times by 4. Now I've got minus 9 over 4 plus 16 over 4, which means we could do x plus 3 over 2 squared, and that would be 7 over 4. So your A would be 3 over 2, and your B should be 7 over 4. So that's how we do a fractional number with completing the squares. Number 4, again, is really, really easy. Okay, number 4 again should be really easy, nothing much difficult there. X squared plus 2x minus 7, half that gives you x plus 1, square it, take that number, square it, and then subtract it. So that's 1 squared, which is 1, subtract it on the outside, minus a 7. So we are talking about x plus 1 squared minus a 8. So A would be 1, and this time it is a plus b, which means b is minus 8. So that's the first time we're getting a plus b thing. Okay, this one would be slightly different, but we have done these questions in class, so shouldn't be that difficult. Okay, so we've got 2x squared plus 8x plus 3. What we can do is we can kick that 3 away. We can bring him back later. Factor out the 2 from these two things. So that will be 2 lots of x squared plus 4x. So we're going to focus just on the x squared plus 4x part. So we know how to complete the square for x squared plus 4x. So that will be x plus 2 squared, and then take this number, square it, and then subtract it. So that's would be minus 4. So in place of x squared plus 4x, I could actually write x plus 2 squared minus 4. That means I could say this is 2, and inside of the bracket I could write what I have figured out in red, which is x plus 2 squared, and then minus a 4. Now remember, we've got to bring that 2 back. So what we're going to do is we're going to multiply that 2 inside the bracket. So the 2 lands here because it's getting multiplied to the first bracket. And 2 gets multiplied there as well. So now we have 2 lots of the x plus 2 square, and then 2 lots of negative 4, that becomes negative 8. But we're not done yet. We still have this plus 3 still on the outside. So this now becomes 2 lots of x plus 2 squared, and then this becomes a minus 5. So the trick here is we are kicking that 3 away. We're changing the 2x squared thing into a normal x squared. We're factorizing a 2 from that so that it looks something like an x squared thing. We complete the square on the side. We take that answer and we bring it back into this bracket. Once we've got it there, we can now bring back the 2 by sort of expanding a bracket or multiplying inside. Once we've done with that, we can bring back the 3, and then you can simplify your answer from there. Okay, that's number 5. Number 6, this is easy, maybe just for the fraction, but we'll still do that. Right, okay, so okay, let's just put this there. Okay, so again, we need to take this number and then half it. So there is an invisible 1 there, which is the coefficient. So we've got x squared minus 1x plus 5. Take that number, half it. So that will be x minus a half squared. Take that number, square it. So that's a quarter. Subtract it on the outside, and we've got a plus 5. So we're going to go back to our fractions lesson. Add 5, denominator is 1, get the common denominator by multiplying by 4. That's negative 1 plus a 20, and then that's common denominator 4. So we now have x minus a half squared, and then that would be plus 19 over 4. So that should be that. Okay, so after completing the square, we have to now give, or we are trying to solve solve an equation giving our answer to 2 decimal places. So that's not something new. This is an application of, or this is where we actually use completing the squares for some useful purposes. Turning point is another one. We're going to actually use the whole complete the square technique to sort to get to an answer. So what we can do is x squared minus 7x. There are two ways of doing this. Because we are more used to having 3 terms, I'm going to keep this as minus 10 equals 0. You can also keep the 10 on the other side and then solve it from there, but because we are usually more comfortable keeping or having 3 terms, I'm going to keep the 10 there. So now we have x minus, I wouldn't use 3.5, I'm just going to use 7 over 2. It's going to be x minus 7 over 2 squared. Take that number, square it. That's 49 over 4. Subtract it. Then you have a 10 on the outside equals 0. We're going to try to get a common denominator, which means times by 4 times by 4. So I now have x minus 7 over 2 squared. And then that would become minus 49 minus 40. So that's minus 89 over 4 equals 0. And because now I've completed the square, because I'm trying to solve for x, the objective is I should be left with an x at the very end. So that means I'm going to try to move all the other numbers onto the right side, except for the x, which would be left alone by itself at the very end. So the first thing that I could move is add 89 over 4, add 89 over 4. That gives me x minus 7 over 2 squared equals 89 over 4. The easiest thing I could do now is, or to get to my x is, I could square root it. So if I square root on both sides, I would now have the square and the square root, they would undo each other. So I now have x minus 7 over 2 equals plus or minus square root 89, and then square root of 4 would be 2. I'm using the plus or 9. You could use it either for one of either the numerator or the denominator. You don't have to use it for both of them. Now the last part is we need just the x, so I could add 7 over 2 and then add 7 over 2 on the other side as well. So that kind of gives me x equals, so the negative 7 over 2 positively, that goes off, giving me 7 over 2 plus or minus square root 89 over 2, which means I could combine both these answers, saying 7 plus or minus square root 89 over 2, which means I've got myself two answers. One is 7 plus square root 89 over 2, and the other one is 7 minus square root 89 over 2. And I'm pretty sure you all know how to plug that into your calculator and then give your answer to 2 decimal places. So I'm going to skip that. So that's how you actually solve a question by completing the square. So the technique in solving is once you have done completing the squares, you try to kick away all the other numbers, trying to get to just the x by itself. So once you've got that squared bit, the easiest thing to get rid of the square would be square rooting on both sides. Remember to have the plus or minus in your answer as well while you're calculating your final answer. Number 8, without expanding, show how to find exact solutions. Okay, we can't expand the brackets, but we are trying to solve this equation there. So it is pretty similar to what we literally did a few seconds ago. So we have 4 lots of x plus 7 squared equals 25. Remember, we are trying to get to x because that is what we are solving. So we'll try to kick away everything else other than the x. First thing that we could do is divide by 4, divide by 4. Don't try square rooting straight away. I think division by 4 should make things a bit more easier. So we have x plus 7 squared equals 25 over 4. Now we can think of square rooting. So we have x plus 7 equals square root of that, which should be plus or minus 5 over 2. So the final answer would be subtract 7 on both sides. So that's minus 7 minus 7. So x would be equal to minus 7 plus or minus 2.5. So we've got two possible answers. It could either be minus excuse me, 9.5, or it could be minus 4.5. Is it? Yeah, minus 4.5. So two possible answers from there. Where did those two come from? Well, basically you just do either minus 7 plus 2.5, or you could do minus 7 minus 2.5. So yeah. Again, same technique with solving the question. Number 9, solve the equation by completing the square. So again, this time you're solving the equation, pretty much the same technique that we did earlier. We are first completing the square, then we are trying to solve the question. So right, okay, so we've got x squared minus 2x minus 11 equals 0. First step, let's try to get this into a completed squared version. So that would be x minus 1. We're halving that number, squared, take that number, square it, and subtract it on the outside. So that's minus 1. Have minus 11 equals 0. We're going to keep, okay, let's just tidy this up then. Minus a 12 equals 0. We're going to keep everything other than x. That means we're going to keep x and then kick out everything else. So that's x minus 1 squared equals a positive 12. We're going to square root on both sides. So that gives me x minus 1 equals plus or minus square root 12. And once you're done with that, we could just add a 1 on both sides. So that gives us x equals positive 1 plus or minus square root 12. That means you've got two possible answers, 1 plus square root 12, or you have 1 minus square root 12. And I'm pretty sure all of you know how to plug that into your calculator. And then you should be able to get your answers correct to 1 decimal place. Number 10, again, pretty much the same idea. Number 10, number 10, number 10. Okay, so number 10. So we're going to do 25. And then we've got 2x plus 3 squared equals 16. So first thing we're going to do, we can divide the 25 on both sides. So that gives us 2x plus 3 squared equals 16 over 25. Get rid of the square by square rooting. So that will be 2x plus 3. So the square and the square root, they kind of cancel off each other. But then on the other side, when you square root it, that should give you a plus or minus 4 over 5. So now it looks like a pretty easy equation. So that means you could say 2x plus 3 equals 4 over 5. Or you could also say 2x plus 3 equals minus 4 over 5. I'm pretty sure we know how to sort that out from there. So you now have 2x equals 4 over 5 minus a 3, so that's, I guess, 4 minus 15, common denominator, times by 5, times by 5. 4 minus 15, that's minus 11 over 5. So that's 2x equals that. And then maybe this is a good technique that you can remember. If you're trying to divide, bring that number to your denominator and then get it multiplied with. That's another technique that you can think of. So this would be minus 11. 5 times 2, that would be 10. So this would be minus 1.1. On the other side, we've got, we're going to subtract 3. So this time it would become 2x equals minus 4 over 5, and then this would be minus 15 over 5, so that would be 2x equals minus 19 over 5. Again, if you want to bring the 2 into the denominator, think of that as a multiplication of the denominator, giving you x equals minus 19 over 10, or minus 1.9. And that's question number 10. Question number 11. Again, another use of the completing square method, where we are actually finding some inference or conclusion after you have completed the square, using that completed square method. Okay, so we've got x squared plus 12x plus 11. So take this number, half it, that would be x plus 6. Take this number, square it, so that's 36. Subtract it on the outside. That's that. Now bring back your plus 11. So this would be x plus 6 squared minus 25. That part is done. If you want to find the coordinates of the turning point, the x coordinate is given by, remember, you need to flip the number, so that would be minus 6. But the number that's on the outside, you just basically copy and paste. So that's your control C and your control V. So basically you copy that number and you paste it. So that's minus 6. So the coordinates of the turning point are minus 6 and then minus a 25. And that is another use of actually completing the square. This is slightly a bit more interesting question. It's where you could actually think a bit more while you are solving the graph question. So the question is, which of these graphs is a representation for y equals? So let's try to think a bit more. Now, when you say y equals x squared minus 6x plus 4, that doesn't really give us any insight. What we can do is, maybe if we complete the square, we might be able to find something about the turning point. So that gives us x minus 3 squared. Take that number, square it, that's 9, subtract it on the outside, and then add the 4. That means this is x minus 3 squared minus a 5. That kind of gives me an idea that the turning point of this curve or this graph should be a positive 3, because I know I have to flip that, and the y coordinate would be minus 3, 5. So I want you to look at all these 3 curves. See if you can spot a 3 minus 5. This is not a 3 minus 5. That's 100%. We're sure. Here the y coordinate is a minus 5, so that part is agreed. But the x coordinate, that's not a 3, that's some negative number. Okay, so because it is a negative number, I know that this is also not the graph. Then that obviously brings us to C, Well, we can see that the y coordinate is a negative number. The x coordinate is also a positive number. So definitely C would be the answer. So when you're given a y equals x squared minus 6, that doesn't really give you an idea of how the shape or where the turning point looks like. So we try to complete the square and then get to the answer from that. Last one is supposed to be the most difficult one, so let's have a go at that. Oops. Okay. So the point 2, 1 is the turning point of the graph with the equation blah 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 blah, where a and b are integers. Find the values of a and b. We know it is a turning point, which means I could plug in 2 as my x value and then 1 as my y value. So remember that idea for me, guys. Whenever you know that a point is passing through, or a curve is passing through a point, it could be a graph, it could be a parabola, it could be a straight line, any curve for that matter. If the point actually lies on that curve, or if it is passing through that curve, your x and y coordinates will fit perfectly into the equation of the curve. So because I know that this is the turning point, that means I know that 2 and 1 will fit perfectly into this equation. That means I could plug in x as 2 and y as 1. So if I do that, I get 1 equals, what do we get? 1 equals x squared becomes 2 squared, ax becomes 2 times a, and then that would be plus b. So now we have 2a plus b plus 4 equals 1, or 2a plus b equals minus 3. That's the first equation. Again, let's see if we can find out anything about the turning point, or maybe we could do a bit of completing the squares. That should be an option. So that's going to be a bit more trickier, but we could definitely try that. So maybe that's the best possible way. So if we do y equals x squared plus ax plus b, remember this number, which is a, we're going to halve that. So this becomes x plus a over 2 squared, and then take that number, square it, a squared over 4, subtract it on the outside, then you have plus b. So we've kind of made a turning point thing. Well, that means this number a plus 2, I need to flip that if I have to get to my turning point. That means minus of a plus 2 would be my x coordinate. And do I know the x coordinate of my turning point? Yes, that is 2. Which means I could say this x coordinate is equal to 2. So minus a equals 4, or a equals minus 4. There we go. That's our first breakthrough. I got a as minus 4. Now that I've got a as minus 4, I can go back in here and then do something with that. Or I could go back there and then do something with that. Whichever one you prefer, you could try whatever you feel is convenient. For me, the first one looks easy. because 2a's would now become minus 8. So minus 8 plus what would give you minus 3. Obviously, that means b is equal to 5. Let's try it with this method. So if you want to do it with this method, a is minus 4, so that means a squared would be 16. So now I've got negative of 16 over 4 plus b. And then that will be negative 4 plus b, because 16 over 4 that becomes. So I know this number, or this part here, is the y-coordinate of the turning point. And if I go back to my question, the y-coordinate of the turning point is 1. So I can then say for sure that this number, or whatever that quantity is, has to be equal to 1. So add 4 on both sides. B would be equal to 5. So whichever method you prefer, you could try that, and then you should be able to get the same answer. So the last one is supposed to be the most trickiest of all. And then, other than that, I think that looks straightforward. So if you have any questions, you can leave a comment, or you can just let me know if you have any doubts while we are in lesson. Hope this helps. I think I should be able to post the workings as well. If not, you can just go back and then pause and then maybe rewatch the thing. Maybe, yeah, that should help. That's it for this week.